Welcome, guys, to the discussion of the section 4 of this test paper, the final section, where we have three single choice questions to discuss. Let us discuss them one by one. Consider the circle given by this, okay, where a and b are non-zero real numbers. Two distinct chords of the circle are drawn from the point a comma b by 2 such that both the chords are bisected by the x-axis. Which of the following can be a valid choice of the ordered pair a comma b? ठीक है. अब देखो, ये जो पॉइंट है जिसमें से ये कॉर्ड पास कर रहे हैं, this point lies on this circle, right? Because here if we put x equal to a and y equal to b by 2, this vanishes. Okay, that means if we try to draw the diagram here, let's say this is our circle, and this point is a comma b by 2. Okay, and the x-axis is like this, for example. So if we have two distinct chords passing through this point, then both of these chords are bisected by the x-axis. Okay, this is x-axis. So this chord is bisected at this point. Let's say this point coordinate is x1 comma 0, and this point here coordinate is x2 comma 0. Okay, then we have to select a valid choice of the ordered pair a comma b. Okay, now how to approach? What will be our approach? Okay, so we can connect this situation to quadratic equations. How? Let's say if I try to represent the situation that a chord passing through the point a comma b by 2 is bisected by the x-axis at some point x comma 0, capital X comma 0. Okay, then that will be a quadratic equation in capital X, right? Because if we try to write the equation of the chord, we know the equation of a chord with a given midpoint is t equal to s1, and in the s1 term we will have x squared, right? If we try to look into the midpoint coordinate will be capital X comma 0, because the point is lying on the x-axis, right? So if we try to write s1, there will be a capital X squared term. That means we will get a quadratic equation in capital X, right? So if we are drawing two distinct chords of the circle, then we will have two different capital X, right? Capital X1 and capital X2. That means what? That means the quadratic equation whose roots are capital X1 and capital X2, the quadratic equation must have distinct real roots. That means the quadratic equation that we will get will have its discriminant greater than 0. Okay, so we have to find the quadratic equation first. Now how to find that? Easily we can find the equation of the chord by t equal to s1. So t is what? If we try to write the circle equation first, so circle equation is 2x square plus 2y square, then minus 2ax minus by equal to 0, right? So t will be what? T will be simply 2 times small x times capital X plus 2 times 0 times small y, so 0, minus 2a small x. That means 2a times small x plus capital X divided by 2, minus b times capital Y is 0, right? So this will be y plus 0 divided by 2 equal to 0. That means this will be our t equal to 0, right? So t equal to s1 we have to write. So s1 will be simply substituting small x equal to capital X and small y as 0. Okay, so this will be 2 capital X square minus 2a capital X. That means this is the equation of the chord, right? This is the equation of this chord. Now note that this chord also passes through the point small a comma b by 2, right? So we just satisfy the equation with small a comma b by 2, right? So we get 2 times small a capital X minus 2a times a plus capital X divided by 2. So this 2 we can cancel. minus b square by 4 equal to 2 capital X square minus 2a capital X. Okay. So from here we can write 2 capital X square minus 4 small a capital X. Then we have minus a square, so this will be plus a square. Then we have minus ax, that means plus ax, and we also have this plus a square by 4 equal to 0. That means 2x square minus 3ax plus a square plus b square by 4. This is equal to 0. Now this is a quadratic equation in capital X, right? Whose roots are capital X1 and capital X2, such that x1 not equal to x2 and both are real. Okay. So that means the discriminant must be greater than 0, right? So we have discriminant as 9a square should be greater than 8 times a square plus b square by 4. That means this will be a square greater than 2b square. This is the condition. Okay. So if we check the given options here, this a square is greater than 2b square, so a square minus 2b square must be positive. So a square minus 2b square for this option is how much? This is 4 minus 2 times 4, this is less than 0, definitely rejected. Then 9 minus 2 times 4, this is positive. Okay, so this is acceptable. Obviously this will be not acceptable because this is a single choice questions and none of this is not correct, right? So option B will be our correct option. Okay, let's jump to the next problem. The next question is saying the value of this product of this expression root 3 plus tan of k pi by 180 from k equal to 1 to 29 is 2 to the power n, where n is a natural number. Then we have to find the value of n. ठीक है, तो हमारा गिवन एक्सप्रेशन है k equal to 1 to 29, this product root 3 plus tan of k pi by 180. Now this is a continued product. Okay. Now generally in this type of questions, we solve the question by telescopic method. We generally form a telescopy. Okay. So that terms cancel. That will be our approach. So first of all, our standard approach that we have to take is break the tan, cot, cosec and sec into sine and cos. Okay. So convert everything into sine and cos. That's it. So let us do this. Product of k equal to 1 to 29, then root 3 plus this will be sine of k pi by 180 divided by cos k pi by 180, right? So this thing we can write as product of k equal to 1 to 29, then this we can simplify as root 3 cos k pi by 180 plus sine k pi by 180, right, divided by cos of k pi by 180. So for simplicity we can actually convert the radians into degrees. Okay, तो चलो डिग्री यूज करते हैं यहाँ पे. तो हम लिख सकते हैं इसे k इक्वल टू 1 to 29 दिस प्रोडक्ट रूट 3 cos k डिग्री प्लस sin k डिग्री. Okay, divided by cos of k डिग्री. Now see here we have this term, this numerator we can easily represent in terms of a single sine or cosine function, right? Now our idea was to use telescopic method, right? So for telescopic method we have to have identical functions in numerator and denominator, right? So we can convert this expression into a single cosine function, this numerator. So we can multiply and divide by 2 here. Okay, so this will be product of k equal to 1 to 29 2, then this will be cos 30 cos k degree plus sin 30 sin k degree, right? So this will be cos of 30 degree minus k degree divided by cos k degree. Okay, now if we expand this we get 2 times 2 times 2, this as 29 times, right? And then we have this thing here. We put k equal to 1, we get cos 29 degree. Then we get cos 28 degree, cos 27 degree, so on up to cos 1 degree. Okay. And also in the denominator, we get the same expression, cos 1 degree, cos 2 degree, cos 3 degree, so on up to cos 29 डिग्री. ठीक है. तो ये टर्म्स तो आपस में कैंसिल हो जाएंगे. तो हमारे पास क्या बचेगा, 2 to the power 29. ठीक है. तो क्वेश्चन में पूछा गया है ये n का वैल्यू, तो n होगा 29. सो ऑप्शन सी विल बी आवर करेक्ट ऑप्शन. ओके. लेट अस जंप टू द फाइनल प्रॉब्लम ऑफ दिस टेस्ट पेपर. तो ये क्वेश्चन क्या बोल रहा है, फॉर n ग्रेटर देन इक्वल टू 1 consider the infinite sequence of circles Cn from n equal to 1 to infinity with radius Rn and their centers on the line y equal to x such that Cn plus 1 is touching both Cn and Cn plus 2 externally. ठीक है. इसमें हम ड्रॉ कर सकते हैं. हमारे पास ये लाइन है y इक्वल टू एक्स. ओके. एंड इसके ऊपर ये C1 है. देन C2 है एंड C3 है. अब देखो क्वेश्चन में बोला गया है कि Cn plus 1 is touching both Cn and Cn plus 2 externally. And also the centers of all the circles must lie on this straight line y equal to x, right? So what will be the diagram here? Diagram will be like this. Okay. Let us read further. Let gamma n denote the circle of radius capital Rn which intersects the circles Cn and Cn plus 1 orthogonally, okay, and whose common chords with Cn and Cn plus 1 intersect at right angles. Let Ln be the distance between the centers of the circle Cn and Cn plus 1, and R1, R2, R3 and Rn are in a decreasing geometric progression. Okay. मतलब ये जो सर्कल्स हमारे पास है इनका रेडियस डिक्रीजिंग जीपी में है. मतलब ये सर्कल्स छोटे होते जा रहे हैं. ठीक है. तो चलो डायग्राम फिर से बनाते हैं. लेट अस फोकस ऑन C1, C2 एंड C3. ओके. सो वी कैन गेट एन आइडिया ऑफ द सिचुएशन बाय एनालाइजिंग ओनली दिस 3 सर्कल्स. तो हमारे पास ये लेट से C1 है, ये उसके बाद C2 है, उसके बाद ये C3 है. ठीक है. ऐसे सर्कल्स छोटे होते जा रहे हैं. ठीक है. पर आपस में सभी सर्कल्स टच कर रहे हैं एंड देयर सेंटर्स लाई ऑन दिस लाइन y इक्वल टू x. ओके. सो दिस इज C1, दिस इज C2, दिस इज C3, दिस इज C4 एंड सो ऑन. ठीक है. अब बोला गया है लेट गामा n डिनोट द सर्कल ऑफ रेडियस Rn व्हिच इंटरसेक्ट्स द सर्कल Cn एंड Cn plus 1 ऑर्थोगोनली. मतलब गामा 1 क्या होगा, इसका रेडियस होगा R1, कैपिटल R1, राइट, व्हिच इंटरसेक्ट्स द सर्कल्स Cn एंड Cn plus 1 ऑर्थोगोनली. दैट मीन्स गामा 1 शुड intersect this C1 and C2 orthogonally. That means if we try to draw gamma 1 may look something like this. Okay, this is gamma 1. So we have the radius of this circle as capital R1, this as small r1, this is R2, this is small r3 and so on. Okay. And also we have another criteria for gamma n, that the common chords of gamma 1 and C1 and gamma 1 and C2 they intersect at right angles. Okay. That means what will be the common chords of gamma 1 and C1? The common chord will be this, right? This. And what will be the common chord of gamma 1 and C2? This will be this chord, right? So they intersect at a right angle. So this angle is right angle. Okay. तो उसके बाद हमें क्या करना है, हमें ये समेशन फाइंड करना है. ठीक है. इनफाइनाइट सम ऑफ ln फ्रॉम n इक्वल टू 1 टू इन्फिनिटी. ये है एल के बराबर एंड समेशन एन इक्वल टू 1 टू इन्फिनिटी आर एन इज इक्वल टू आर। तो हमें चार वेरिएबल्स के ऊपर कमेंट करना है ना, ए डैश आर एंड एल, राइट। तो चलो एक एक करके फाइंड करते हैं इन्हें। तो इस ए को हम इजीली डिटरमाइन कर सकते हैं, है ना। ए क्या होगा, ए इज द सम ऑफ एरियाज ऑफ ऑल सच सर्कल्स सी एन, राइट। सो ए इज सिंपली, वी कैन से a is simply pi r1 square plus pi small r2 square plus so on up to infinity. That means pi r1 square plus pi times, this will be r2 will be some k times r1, right? Because r1, r2 so on up to rn are in gp, in a decreasing gp, where k is lying in the interval open 0 to open 1. Okay, so this will be pi times k times r1 this whole square plus so on. Okay, so this infinite sum we can say this will be pi r1 square divided by 1 minus k square, right. Now let us discuss about this infinite sum of ln. Okay, this term. Now let us try to find a general expression for this ln here. So L1 will be what? L1 will be the distance between the centers of C1 and C2. That means R1 plus R2. L2 is what? L2 is the distance between C2 and C3, the centers of these two circuits. That means R2 plus R3. Okay. That means Ln is simply Rn plus 1. Okay. अब चलो इस कैपिटल Rn के बारे में सोचते हैं, ठीक है। So let us try to draw the diagram in a bigger form and then find out a general expression for capital Rn. Okay. So capital Rn we have to find. So let us say this is our Cn. Okay. This is our Cn plus 1. So the radius of this circle is Rn. This is Rn plus 1. Okay. And this is the circle gamma n. So this is the common chords. And they intersect at right angles. Okay. This radius is capital Rn. Now, if we try to look into this picture here, this line is perpendicular to this common chord, right? So this line will also be perpendicular to this common chord, right? That means if this angle here, if this angle is 90 degree, that means this must be, this angle should also be 90 degree. That means what? That means if we try to represent this distance here, the distance of the center of Cn from the center of gamma n as t1, and then this distance of the center of Cn plus 1 from the center of gamma n as t2, we can say clearly this triangle here, this up to this and then closed, this triangle will be a right angle triangle, right, where the length of the hypotenuse is what, as the circle Cn and Cn plus 1 are touching each other, that means the length of this hypotenuse will be Rn plus 1. Okay, so we can clearly say Rn plus 1 this whole square equal to d1 square plus d2 square. Now if we carefully look into this picture, d1 square and d2 square, these two quantities we can easily find. How? Because we are given that gamma n intersects Cn orthogonally as well as intersects Cn plus 1 orthogonally, right? So we can write by the orthogonality condition that d1 square must be equal to Rn square plus small rn square, right? And also we can write similarly for this case gamma n and Cn plus 1, these two circles are similarly intersecting each other orthogonally. So T2 square must be equal to capital Rn square plus small rn plus 1 square. Okay, so that means we get from this equation small rn square plus small rn plus 1 square plus 2 small rn plus 1 equal to 2 capital Rn square plus small rn square plus small rn plus 1 square. Okay, so this terms cancel and we get Rn equal to root under small rn times small rn plus 1. That means capital Rn must be the geometric mean of small rn and small rn plus 1. ओके, तो हमारे पास जो कैपिटल ए है ये है पाई r1 स्क्वायर प्लस पाई r1 स्क्वायर टाइम्स k स्क्वायर प्लस सो ऑन. That means this is what? This is a GP with common ratio equal to k square, where k is lying in this interval. Okay, so if we try to calculate capital A dash is what? The sum of areas of all such gamma n. That means simply pi capital R1 square plus pi capital R2 square plus so on. Now, if we look into this, we get pi times then summation n equal to 1 to infinity capital Rn square, right? So capital Rn square is what? Capital Rn square is small rn times small rn plus 1. That means pi times summation small rn times small rn plus 1, where n is running from 1 to infinity. That means pi times this we can write as n equal to 1 to infinity. Rn plus 1 we can write as k times Rn. So Rn square times k. Okay. So pi times summation n equal to 1 to infinity small rn square times k. Now this thing is what? This thing is simply we can say pi r1 square plus pi r2 square. This is simply our capital A, right? So this will be ka. That means a dash equal to ka, right? Now as k is less than 1, this a dash must be less than a, right? So a dash is definitely less than a. This is our first condition. Okay, so let us check the option. So option A and option B are clearly eliminated. Okay, here a dash is greater than a, which is not possible. So we have to now comment on R and N. Okay, so R is summation Rn, right? R is summation n equal to 1 to infinity Rn, which is we can write small Rn times small Rn plus 1 under this summation from n equal to 1 to infinity. And what is L? L is summation n equal to 1 to infinity capital Ln, which is summation n equal to 1 to infinity Rn plus 1. Now the question is which one will be greater? Okay. Now to compare this, we use AM and GM inequality. Now you may ask me, how does this approach strike your mind? Right? How can we know that we have to apply AM and GM inequality here? Well, we can clearly see the forms here, right? This is nothing but geometric mean of Rn and Rn plus 1, right? And this is nothing but 2 times arithmetic mean of Rn and Rn plus 1, right? So we can say that as Rn and Rn plus 1, they both are distinct terms, right? Because they are in a non-constant GP, in a decreasing GP, right? So Rn plus 1 divided by 2 must be greater than under root Rn times Rn plus 1, right? And also we can say as this term is greater than this term, that means clearly Rn plus 1 will also be greater than under root Rn times Rn plus 1, right? That means if we sum them, we get L is clearly greater than R. Okay, so we can say A dash is less than A and L is greater than R. That means if we check the options, option C is matching. Okay, so option C will be our correct answer. I hope you understood the complex geometry of this problem and how we approached this problem step by step. And lastly, we applied the AMGM inequality to compare these two terms L and R. Okay.